Welcome and greetings from Poland. Hope your weather is better than ours, because today we have quite a rainy day. I will talk about performance in Azure Synapse Analytics and SQL Server Serverless Pool. Exactly. My name is Jakub Wawrzyniak. You can call me Jacob. I'm the CTO of TIDK, which is a Polish company, which has over 12 years of experience in building advanced analytics solutions. We are also, of course, a gold partner of Microsoft, and we have advanced specialization in analytics on Azure. So maybe this is why I am here. Okay, let's go to the topic itself, because as you know, this topic may be quite, how to say, crucial for you if you are thinking about such a workload like Lakehouses and so on. So a few words about Serverless SQL Pool, because I'm aware that after the whole day, you may be all familiar with this concept. But just to mention, Serverless SQL Pool is built upon the distributed query processing engine, where we have one control node, which communicates with application or user by interfaces such as Web Synapse Studio or Data Studio, Azure Data Studio, or other interfaces. And this control node is providing the query between compute nodes. So it depends on the query itself, on the workload itself, how it will be served by the compute nodes. Of course, in the background of all of this is also the Azure storage in terms of Azure Data Lake Gen 2, which is a very crucial part of this solution here. And I will talk about it, of course, later. I will start with a short demo just to show you a few examples of what I did and what I prepared here. I have prepared my lab environment, which consists of a few data sets and a few data sources. So what we have here is I've created, just for the presentation, I've created external data source which connects to my data lake. And I'm using two ways of connecting to my data source, which is very important because considering one of them may have some performance impact and the other may not. What I'm talking about is using shared access signature method to connect to the data source, which is probably in some cases a better way than using the provided by Azure Active Directory pass-through mechanism, because pass-through authentication may have a kind of penalty when querying your data source. So this is the first thing you should be aware of when you're thinking about the performance of your workload. Yeah, I have a few data sets, and I will show you how them look like. I've created two databases for testing my workloads. You may be aware that we can use serverless functionality just as for the ad hoc queries, so we don't need to create any database. You can use this built-in master database to query our data, which is relying on data lake. But if we are thinking about building something persist, so to say, or something that may be used, for example, by other people, by analytics, by other people who are familiar with relational database and would like to use such an interface to query your data, which is relying on the storage, we can create databases which hold, for example, metadata and such things. So I've created two databases. The first one is created with the default collation, which is quite important, and I will talk about it. And the second one is created for querying with a collation for UTF-8 encoding, but also with PIN2 option. So the first example which we have here is we are querying very simple CSV file from my data lake, and yeah, we'll see a kind of information about Pokemons. I hope you like Pokemons, because I like Pokemons. What you can see here is that, of course, yeah, we have this preview of the data, so everything loaded. Yeah, we will not talk about this right now, maybe later. And we have quite a simple structure with headers. This is because why I used this header row option. So it means that the first row in our CSV file should be treated as a header. So we have proper column names. We have hopefully proper values in our data set. And what now? What we can observe that the first query to my data set took around 4 seconds, more or less precise here. 4 seconds. Let's try again. Okay, we can see, and now it took 2 seconds. Why there is a difference between running the same query a few times? The difference is because the first query for your data set, for your data, you should be aware of that it also has some kind of warm-up time. So we need the environment needs time to guarantee the resources to serve our query. So then every query after the first query should have comparable times. So this is the first thing you should be aware of when you are building such a workload. So the first query to your data will always have such a penalty, so to say, of warming up. Okay. What I see here is that I'm using the CSV files, actually one CSV file, and I'm using such option like parser version 2.0. Why I'm using this? Parser version 2.0 is a parser of CSV files which is optimized for performance. So this is definitely something you should be aware of when you're using CSV files and you're building this workload in that way. The second thing that we can observe is that I'm not defining any schema here, because I'm relying on the automated inferred schema, and this is definitely not good approach, because everything which is automated, of course, it's good for us in terms of development, and it makes some things quite easy, but in terms of production workloads, we should always be aware of what are my how my data look like. So yeah, really get to know your data. That's the most important thing, because if we rely on a schema which is provided by me, so I just put it in the with clause, and I build it so that index has a type of integer, and the other text columns have a type of varchar. The other also important thing here is we should always use the lowest possible type, the lowest possible precise, which is able to hold the largest possible value in this column. So we should be aware and not do not use such a constructions like varchar max for each text column, because it has also it can also provide you some kind of penalty in terms of querying, especially very large data sets. So let's try this query and see what happens. Yeah, we are getting quite a good time here. Actually, the differences between the executions will not be very surprising, because we are relying on very small data sets here and one a bit larger. So we will it will be difficult to observe it in this interface. But I will show you the other way to observe the execution times with a more precise. Okay, The other thing we should be aware when querying CSV files is that the CSV data sources, CSV files, do not have enabled, just for now, automatic creation of statistics. As we know, statistics are quite important in terms of querying our data. So in case of using the CSV files, we should be aware that we would need to create the statistics manually by ourselves. How to do that? Well, let's see. We have such a simple query here. We are just querying the Pokédex number from our data source, but we are using the whole schema here. So what we want to have is something like that. It took one second, and we would like to create statistics built definitely for this query. So for now, Synapse Serverless SQL Pool allow us to create statistics only for single columns. So I'm just putting the whole query in the here in the parameter of the stored procedure, which is called sp create open row set statistics. So this is the procedure you should be familiar with when you are planning to use CSV files as your data source. So let's create those statistics. And then let's try again. Query. Yeah, 1 second, but it should be much faster here. We can check that in a minute. The thing which is very useful in checking the performance of our query is a library called QPI, it's Query Performance Indicator. It's the Query Performance Insight is a library created by Jakub and Popovich. So this is very useful because it provides us a few simple queries which we can use to track our queries, to compare our queries, and even to see some recommendations for the objects that we created in our databases. And about recommendations, I will talk later. But let's see how let's look at the query history. So here we have the history of our queries for the Pokédex number. What we can see is that executing the query without computed statistics for this Pokédex number took almost around 16 seconds. So it's something like that. And after we created our statistics, it took almost 1 second. So we have a benefit of few seconds here. So as you can imagine, for the large data sets, the benefit may be very useful here. So this is why managing the statistics is very important here. Of course, there is also a procedure which provides us possibility to drop the statistics, so we can update them, and when our data set changes significantly. And this procedure is called sp drop open row set statistics. And of course, we are using as the parameter our query itself. Yeah. So the one remark we should be aware of is that managing statistics for CSV files, CSV data sources is very important here. And this is the first thing you should think about when you are using CSV files and your query, if the performance of your query is getting worse. So this is the first question you should ask yourself. Do I have do my statistics are up to date? If not, then try to rebuild them. But as I said, for now, we can only build the statistics just for single column just for single column expression. Yeah, I talked about QPI. We will go to this later. The next thing we are talking about in terms of performance is the schema inference, because when we are using the PARQUET files, which is very optimized format for such workloads, because it relies on its column-based format, as you are aware. So if we are using PARQUET files and PARQUET format for our serverless statements, then we can rely. We don't have to provide the schema using the with clause, because we can rely on the automatic schema inference. But the automatic schema inference also has some issues you should be aware of. So again, when we are querying our data in the PARQUET format, and something is wrong with the times we are getting by executing our query, we should think about providing the exact schema. Just for one example here, we are querying our very simple data set with the cases for the COVID disease. It took 2 seconds, but it relies on the automatic schema inference. But if we limit our schema just to the columns that we are interested in by using the with clause and putting the exact types we have here, also these types should be familiar with the PARQUET format. So the matching of the types to the PARQUET is important here. So if we limit it only to those columns, we should get something quicker. Yeah, we have, of course, we've limited the columns, but we also provided better schema here, so we are getting a time of 1 second. Okay, let's see another example of schema inference in terms of building the view, because normally when we are creating such an ad hoc analysis, we are querying the open row set itself, just like I'm doing so. But if we want to make it reusable by other people or by other solutions, we can provide and we can build views in terms of views in our metadata database here. Okay. Here we have another data source. It's a data source, probably you're familiar with it because it's the data about the trips of the yellow taxi from New York City. So if we are querying it in such a way that we are selecting just the data from the 2018, it's taking some time here. Yeah? But what we see here is that we are having some such kinds of data. Okay, let's not wait for this query to end the execution. The Serverless SQL Pool has one very useful stored procedure which we can use when querying the PARQUET files to describe this result set. So we don't have to wait for the result of our query, of execution of our query. We don't have to look inside the PARQUET file. We can use this procedure, which is called SP describe first result set, to have the information about each column which we are using in this query. So what we can observe here is that we are selecting 3 columns: vendor ID, TPEP pickup date time, and passenger count. So each of them is described by some properties here. So we have the information that this column, if this column is nullable or not, and which is more important, especially for columns that are text string columns, we see how will be the schema inferred automatically. So we see that for this column, vendor ID, we'll have something like varchar 8000, varchar 8000, which is the maximum value here, which is not the best option to query such data, because we know from exploring this data set that this vendor ID has a maximum value of 4 length of 4. Yeah, so we can provide the exact schema just like in this example, and with clause we are providing the vendor ID will be varchar with a length of 4, and we also have a TPP pickup data, which is a type of datetime2, and passenger count, which is a type of integer. So if we use this query will be performing much better than the first one. And this is important in terms of building the views, because this show us how this gets us the ability to design our metadata database, which will be used by other users, for example, in a good way. Yeah? So I will not wait also to end this query, but I will show you how to use those data which are relying from this from executing this stored procedure to build the proper view. We have another data set here. We have a data set of COVID diseases, and we will describe it just the way we did so. So let's take this top 100 and star of the PARQUET file. Here we have 6 columns. So we have such columns like location, date, variant, num sequences, and so on. And what we can see here is that this PARQUET file, this will be automatically inferred. The schema will be automatically inferred for each column to varchar with a length of 8000, which is of course the worst case here, because from exploring the data set, we know that we don't have only string or text columns here. We have also the numerical columns, we have integers, and so on and so on. So we can provide this information to build the proper view. So we create a very simple statement. We just create view COVID cases as select star from this open row set. What I'm doing here is I'm just creating. Sorry, this view is. We should drop it. Okay, and let's try again. So we are creating just the dummy view without providing any schema here. And one path to provide it to know it is the path that I showed you, that we can use this SP describe first result set stored procedure, and then we'll probably know how to build our schema. And the other way is that we can use this QPI library by Jovan. So we can use, for example, something like QPI recommendations, which will provide us information about possible optimization options. So here we have this COVID cases. This is what we are interested in. What we see here is we have few options to optimize our workload with a score 1, which is very important here. So we have we can optimize column type for each tag which is here. As you can see, it says that the string column location has a max size of 8000 bytes. Check, maybe we can use something better here. Of course, we can use something better here, and this is a recommendation to always use the most precise schema in our workload. So we recreate our view with a proper schema, which is just exact to serve our data. Of course, in terms of small data sets, we will not see, so to say, huge difference. But in terms of large data sets, in terms of large PARQUET files, even partitioned PARQUET files, we will see the difference, believe me. Okay. The other thing we should be aware of is using of wildcards, because this environment gives us possibility to use wildcards to traverse to the files in our storage. But using such a construction like here in this open row set, when we are using year equal to stars to star, and then month equal to star and start at PARQUET, it means that the serverless SQL pool will start traversing the path from the beginning for each folder, which is exact like this wildcard says. But so as you can, as you know, the star means everything. So we will take every year, every month, and every PARQUET. So huge amount of data here to select just top 100 rows. So what I mean here is that if we can limit our workload to exact partition by using the exact values for our wildcards, we should do so. We should always go to the lowest possible level of the wildcard, because each operation which is relying just on the metadata, so traversing through these values, is much quicker than getting all the data to our memory and then filtering it by other, for example, column or value. So this is something which has very significant, which is very significant in terms of executing query on large data sets. The other example, and for other data sets, just like the same, as I said before, if we are able to limit our partition, we should do so. The other technique we should use to get use of the metadata we have for our partitioned data. So if we have data divided in the folders for year and month, we should consider using such a construction like using the file name function, because file name will provide us the name of each file. We have two such constructions here. We have file name and we have file path, and we will talk about it. How we can use those constructions to select the exact, for example, files which we can use in our query. But because, as I said, these are all metadata operations, which are much quicker than selecting the whole amount of data, putting them in the memory, and then selecting, filtering based on some kind of a predicate here. For example, what we are doing here is we are just getting all the files from one folder for the year of 2016 and second month, and we are calculating number of rows here. It took us 3 seconds for such quite a large data set here. Okay, the other way we can use this file name is provided here, because we can use this file name, for example, to build a special column called file name, and then we can use this file name column, for example, to order our results, or we can use also this file name just to limit the files we are taking in our query. Yeah? So we are again relying on the wildcard, which is a star.csv, but we are limiting this just to the names of these files. This is very good in terms of performance. Okay, the other technique is the file path. The file path provides us a part of the path which is described by the wildcard. So in this example, when we have file names constructed in such a way that this is the text yellow underscore trip data underscore star, then minus star, it means that here we will have the year, and here we will have the month. So why not to use it in our query? Of course, we can do it so. So if we provide the file path without any argument, we will get the whole file path, which we can also store in our, for example, view when creating our workload. But if we will provide an argument, for example, of 1, then we'll get the first element represented by the first star. So we'll have the year, and then we'll have the month. And again, we can use it in terms of querying the exact files here, or we can use it for creating some kind something called partition view. Just imagine we would like to use this data of from the data set of taxi trips to create the view which will be querying anytime we want. We have two options to create such partition view. First option is that we are getting all the data from all the folders. So we are traversing the whole path, which is not performing very well as we know. And then we are calculating 2 special columns here. So we are getting this year and month function based on this TPEP pickup date time. So we are calculating them to use them in our query to filter the result, just like here. So we can use year and month in such a way. Of course, as you can imagine, this option is not so good because we are getting the whole amount of data just to calculate this year and month values, but we can do so. Check how does it look. The view is created, and then we are executing this query. And what we see here is it's taking some time to start executing, to start showing us the results. Even if we are limited just to 2016 and the month. I will not wait for the execution to start, but believe me, it is much worse than the second option I will show you. And the second option is that we are creating the same view, but with using the possibility of file path. Because we are, what we do here, the wildcard looks more or less the same, but what we do, we are getting this file path argument of 1 and file path argument of 2 to create such a columns of year and month also. But this operation will be much quicker than the first one. So we should observe significantly quicker execution here. And finally, we should see that the results, are showing much quicker than in the first case. So these are very simple techniques you should be aware when you are thinking about your the performance of your workload. One other thing, just a quick recap of this, is what is very important is of course the collation of our database, because especially when we are querying data from PARQUET files, which consists, for example, text or string literals, it is important to use the proper collation. Here we have a collation of UTF-8 bin2, which is the only collation for now which can use this mechanism for PARQUET files, which is called the predicate pushdown, which provides much better performance in terms of selecting data and filtering with using this using the string literals. Okay, let's go back to the presentation. So to sum up best practices, a few things we should be aware of when thinking about the performance of our workload. There are some kind of obvious things we should also be aware of, like other region proximity. So if we are querying, if I'm using the Synapse workspace, which is located in the nearest region to the Poland, of course, I will get better results in terms of performance than using the Synapse region, for example, from the US, which is quite, which is much bigger distance from our country. The other thing we should be aware of is the collocation of resources. So if you are thinking about Synapse, we think about the Azure storage, I mean the data lake storage, but also Azure Synapse workspace. But if we want to have also access to data from our on-premises or something like that, we should collocate resources as close to the to our on-premise as possible. We should be aware of storage layout optimization techniques, like in many cases using the PARQUET files, so converting our data sets to PARQUET files provides us much better times in terms of performance than using large CSV files or even JSON files. So this is something you should be aware of. Also, splitting into smaller files, just not putting all data in one large PARQUET file, but splitting it into smaller files, just to get use of all those mechanisms that HDFS, PARQUET, and Spark have together. Equally sized files are better, so this is about the distribution of the data. So when we are designing our storage layout, we should consider such things. Those techniques of targeting specific partitions, so using file path and file name, are also important here. Pushing wildcards to lower levels in the path. So if we can limit our data sets in terms of using the exact value for a given wildcard, we should do so. We should not overuse the star definition because it has very, very large impact on the performance. The other thing, appropriate data types. We should use the smallest data sets that can accommodate the largest possible value, especially important in terms when we are relying on the automatic schema inference for the PARQUET files. CAR and VARCHAR are better than NCAR and NVARCHAR if possible, of course. We should use integer-based data types if possible because they are performing much better, especially in clauses like where, order by, group by, and so on. Of course, using the appropriate tool to query large data sets, because what I showed you is the Web Synapse Studio, which is not the best option to serve the large data sets. Because it relies on the HTTPS protocol. So if we want to query very large data sets, we should rather use Azure Data Studio or SQL Server Management Studio. This Bean2 UTF-8 collation while filtering by string column, which is very important because we can get use of this very good performance here. When we are building a solution which is connected, for example, with Power BI, we should consider that maybe caching some kind of results in Power BI or other solutions like other analysis services is much better option because Serverless SQL Pool is not built to serve such amount of data. So if we want to build so-called Lakehouse based on Serverless SQL Pool, we should consider caching their results. Also, we should be aware of some kind of Azure storage throttling because we should not stress out our Azure storage in terms of putting many queries in parallel. because this is something which may be significant in terms of performance. About Azure AD pass-through versus SAS, I talked about it before. What I recommend is using this query performance insights library created by Jovan. 3 very important queries. So we can select currently running queries and observe what are the times. We can select historical queries, and then of course we can show recommendation of changes in types, collations, etc., etc. In terms of querying CSV files, we should always use performance optimized parsers of the parser version 2.0, and we should be aware that using and managing the statistics will get us better query plan. So again, those 2 procedures, so create open row set statistics and drop open row set statistics, you should be familiar with those procedures. In terms of querying PARQUET files, this is the thing which is very important is utilizing this predicate pushdown. But one remark here: it works only for collation, which is shown here. And of course, the thing we talked about is automatic schema inference versus specified schema. Always it is better to specify schema to have better performance of our query. So the most important remark is get to know your data, because if you know how your data set look like, if you know the skewness, the kurtosis, and such parameters, then you will know how to model your workload where probably you can have a problem with querying your data. And I think that's it. That's a quick recap on the performance of SQL Serverless SQL Pool. Thank you.